As thank you, students. I am going to discuss here last topic for you that's called conocoid. Okay, conocoid. So, what's the meaning of the conocoid first? Conocoid. So, conocoids are the geometrical pictures, particularly the three-dimensional part of a cone are called conocoids. We have heard about the parabola, or we can heard about the ellipse, we can heard about the sphere, like that. Those are two-dimensional pictures. But if you take the three-dimensional pictures, then we can call it as a conocoid. So conocoids are three-dimensional objects coming from three-dimensional cones, parts of three-dimensional cone. We call it as conocoids. Okay, so now look at this. So one first example for conocoid is ellipsoid. Ellipsoid is one type of conocoid, we say. Okay, now the equation of this conocoid is this. Equation of the conocoid is x squared by a square. Let me bring that down so that you can understand that this is equation of the conocoid: x squared by a square plus y squared by b square plus z squared by c square equals 1, where a, b, c are constants. So the set of points x comma y comma z which satisfies this particular equation is called a conocoid. So conocoid are nothing but set of points x comma y comma z with some a, b, c satisfying this equation is called an ellipse. This is one example for conocoid. Okay, so what is a picture look like? Okay, now look at this. This is the picture of conocoid. Picture of conocoid. Picture of a conocoid, where 0, that is not 0 here, O is the origin. O is the origin. This is x-axis, this is y-axis, this is z-axis, and this is what the shape of a conocoid. Conocoid, I mean that the set of points which satisfies this particular equation will give you a three-dimensional objects like this. So all the points on this will satisfy this particular equation. Therefore, this particular picture, three-dimensional picture, we call it as a conocoid. Now look at this. If from here to here the distance is a, then from here to here the distance is a. So the total distance which cuts the x-axis is to a. Okay, and this particular point is minus a, this particular point is plus a, so total distance is to a. That's what we have to understand. Now instead of taking this on the x-axis, we can take on the y-axis also, we can take on the z-axis also, y-axis also, we can take the z-axis also. Okay, in all the direction we can have a different length. Suppose this is from here to here it is b, then the opposite direction it is minus b, the total is 2b. Similarly, this direction it may be 2c, like that. Suppose this, instead of the straight line, this point is lying here, then we call it as a principal axis. Principal axis, that's what we say. I mean, if this minus a is not here but in this axis, then we will have a principal axis. We have principal axis. Now let us go to the next conocoid example, is that hyperboloid of one seat. Hyperboloid of one seat, that is set of points which satisfies this equation, that is x squared by a square plus y squared by b squared minus z squared by c squared equal to 1. This is called, we call it as set of points to satisfy this, we call it as hyperboloid of one seat. We say hyperboloid of one seat. Okay, hyperboloid of one seat, we say. So set of all the points which satisfies this particular condition. The set of points, if you plot on the graph, on the three-dimensional graph, what you'll get is this. That's what you are going to get, the white color picture. Okay, that's what you are going to get. Otherwise I will show that. Yes, this is what white color picture. Okay, this is what we say the hyperboloid of one sheet. Where this comes from? The set of points to satisfy this particular equation. Those points, when you plot on the three-dimensional geometrical space, then what you get is this type of picture you will get, and this is called hyperboloid of one sheet. Okay, here also we have origin. This is x-axis, this is y-axis, and this y-axis, this is z-axis. Here also we have the principal axis. Okay, principal axis, and also the distance we have on the either side. That's very important thing that we have to understand. Now this is what we talk about that. Now coming to the third example for ellipsoid is hyperboloid of two sheets. Hyperboloid of two sheets. So this is hyperboloid of two sheets. So the set of all the points which satisfies this equation, that is x squared by a square minus y squared by b square minus z squared by c square is equal to 1. We call it as the set of points, I mean x comma y comma z, we satisfy this condition. Okay, if you plot them in the picture, what you are getting is this picture you will get. Okay, like this, both sides we have the parabola like that. This is the origin, this is one side x, this is x dash like this, and this particular picture you will get if you plot this set of equations x comma y comma z for the constant a b c. We get the picture like this, and this we call it as hyperboloid of two sheets. Hyperboloid of two sheets. Okay, here also we have the principal axis. As I told you that if you are not taking this axis as a straight line axis, if you taking this minus a in the this x or this axis, what you get is a central axis you will get. Okay, so this also have the central axis. This hyperboloid of one sheet also have the central axis, and hyperboloid of two sheets also have the central axis. Therefore, all these conocoids, these three conocoids, we call it as a central conocoid. A central conocoid. That's what we have to understand. So, with that, I am come to the end of this. I have to come to the end of this particular session. In the another session, we will be discussing about the other chapter. Okay, so till the end, I have to say a goodbye to all of you at this moment. And the next class we will be discussing about different topics. But in this class we talked about what is a conocoid, then ellipsoid is one example for a conocoid, and hyperboloid of one sheet is the another example for the conocoid, and third conocoid is this one, that is hyperboloid of two sheets. Okay, so okay, we will see in the next class. Thank you.